The ocean floor, a realm of perpetual twilight, holds secrets as numerous as the stars above. Among the most captivating are the brine pools, underwater lakes of super salty water, distinct from the surrounding ocean. Shimmering like mirages, these pools appear almost otherworldly, their surfaces reflecting the faintest glimmer of light from submersibles miles above. Their stillness, however, is deceiving, for within their depths lies a story of geological upheaval, chemical magic, and life adapted to extremes. Imagine descending through the inky blackness of the deep ocean, the pressure mounting, the temperature plummeting. Suddenly, a ghostly glow appears below, resolving into a pool of shimmering water. This is no ordinary body of water. This is a brine pool, a cauldron of ancient seawater, far saltier than the surrounding ocean. The Gulf of Mexico, a seemingly familiar body of water, harbors many such pools. Their existence, hidden beneath thousands of feet of water, remained unknown until relatively recently. Now, with the aid of remotely operated vehicles, ROVs, we are beginning to unveil their secrets. These underwater lakes, often described as underwater jacuzzi of despair due to their lethality to most marine life, are anything but desolate. They are teeming with life, albeit life that thrives in conditions toxic to most. The brine pools of the Gulf offer a glimpse into the extreme environments that life on Earth and perhaps beyond can not only tolerate but conquer.
The formation of a brine pool is a story written in the language of geological time, a tapestry woven from ancient seas, shifting continents, and the slow, inexorable forces of plate tectonics. Millions of years ago, as the supercontinent Pangaea began to rift apart, a shallow basin formed that would eventually become the Gulf of Mexico. Over eons, this basin became a giant evaporation pond. As seawater evaporated, it left behind thick layers of salt, sometimes thousands of feet thick. These salt deposits were eventually buried beneath layers of sediment, creating a geological pressure cooker. Fast forward millions of years, and the heavy sediment layers above the salt began to push down, squeezing the salt deposits. This pressure, combined with the movement of tectonic plates, caused the salt to flow and deform, creating dome-like structures known as salt diapirs. Occasionally, these salt diapirs breached the seafloor, allowing seawater to seep down and dissolve the salt. This highly saline water, denser than the surrounding seawater, pooled in depressions on the seafloor, forming the brine pools we see today. These pools are not static entities. They are dynamic systems, constantly evolving in response to geological and chemical processes. Faults and fissures in the seafloor allow for the continual seepage of seawater and other fluids, replenishing the brine and influencing its unique chemical composition.